So this is the final video for partial fractions for A2 Maths, and this one involves in improper fractions. So an improper fraction within algebra is one where the degree of the numerator is equal to or greater than the degree of the denominator. That sounds like a bit of a mouthful, but it's not so bad. On the top here we have a quadratic. On the bottom we have a quadratic, so the degree here is degree 2 for quadratic, degree in the bottom is degree 2, so that's equal to, so we can't do partial fractions for this until we do our long division first. If we flip over then to our example 2, which we're going to do in a wee second. The degree here is 3, that's a cubic on the top. The degree here is 2, that's a quadratic in the bottom, so that is a partial fraction. Again, we can't do that until we divide through first of all. We can't deal with partial fractions until that. Unbeknown to you, any of the ones you've done in the first two videos or any of the ones in the first load of examples have all been lower degree here than we have here. And without that, but the first thing you always need to do from now on is to check and see if the degree is the same or higher, then we need to divide through and change it then into a mixed number. Let's go back to some year 8 maths. And take a wee look at this. Say we have 7 over 3. You guys know this as a top heavy fraction, so if we divide the 3 into the 7, it goes in 2 times. 2 times 3 gives me 6, and I have 1, so it's 2 remainder 1. How do we write that? So 7 over 3 is then going to be written 2 1/3. Sorry if this seems very straightforward for you, but it's just to kind of help us whenever we actually try and do these partial fraction examples. So let's take a wee look at the first one. So we need to divide this through. I hope it's obvious to most people we're going to need to multiply this out first. So we're going to go x squared plus 5x plus 6, and we're going to divide that into 2x squared plus 8x plus 7. People get a bit confused with this, so let's see if we can work out what's going on. X squared into 2x squared, it goes 2 times. We then do 2 times this, which gives us 2x squared plus 10x plus 12. We subtract then to get our remainder. These obviously cancel. This take away this is minus 2x. This take away this then is minus 5. So how can we rewrite then our original question? This is the big mummy question. So we have x squared plus 8x plus 7 all over x plus 2 x plus 3. I'm actually going to go back here to our top heavy fraction here. We remember 7 over 3 we could write as 2 1/3. So what's the 7 bit? That's here. The 7 disappears. The 3 is still at the bottom. The 2 1/3. So that's going to be then 2. And then I'm going to change that plus. Here's our remainder, which is our equivalent of our 1 minus 2x minus 5 all over x squared plus 5x plus 6. I hope you see what we've done there. Now we're just going to do our partial fractions for this, and remember then to put the 2 at the front at the very end. So how do we do partial fractions for this one? We split it up into 2 factors, so let's take this wee bit down. It's minus 2x minus 5 all over x plus 2 upon x plus 3. We would write that as a over x plus 2 plus b over x plus 3. A upon x plus 3. Remember we're times top and bottom of this one by x plus 3, top and bottom of this one by x plus 2. X plus 2, and that then would be our top line with a common denominator of x plus 2, x plus 3. Looking at this then, this is going to be the same as this with the top line, so I can put those equal to then, so minus 2x minus 5. Whenever I let x equal minus 3, I'm going to have 6 take away 5, sorry, wait a minute, what am I doing? X is minus 3, that gives me 6, it does give me 6 take away 5, which gives me 1 equals minus b, and so I get then b equals minus 1. If I let, sorry, can't even see this, apologies. If I let x equal to minus 2, what's that going to do here? Minus 2, so it's going to be 4 minus 5, so that's going to be minus 1 equals minus 2, that disappears there. Minus 2 plus 1 is a, so my a then is minus 1 as well. So how can I rewrite my final line then? I can just fit it in here at the bottom. So what was my question? My question was 2x squared plus 8x plus 7 over x squared plus 5x plus 6 split up into its partial fractions is equal to 2, because that was the wee bit from up above, if you remember, minus 1 over x plus 2 minus 1 over x plus 3. Let's take a look at our other example. Again, the first thing you do from now on for all partial fractions is look and see, is the degree of the numerator equal to or higher than the degree of the denominator. If it is, then you need to divide through first. This is a cubic, it's degree 3. This is a quadratic, it's degree 2. So we need to divide through first. So let's do that. X squared plus 5x plus 4. And we're going to divide that into x cubed, I don't know if you remember this from last year, plus 3x squared plus 0x plus 10. It just makes our dividing a wee bit more straightforward. X into this, so x squared times what is going to give me x times this by this. I'm going to get x cubed plus 5x squared plus 4x. I then subtract these, that's going to cancel. Minus 2x squared minus 4x plus 10. Remember again, I'm now dividing this into this. X squared times what gives me minus 2x squared is of course minus 2. And that's minus 2x squared minus 10x minus 8. That gives me then 6x plus 18. So I can now rewrite this original question as being equal to, excuse some dodgy notation here, x minus 2 plus 6x plus 18 all over x squared plus 5x plus 4. What do? I do my partial fractions then for this bit here and try and solve it. So let's take this wee bit down. We have 6x plus 18 all over, factorising that is going to give me x plus 4 upon x plus 1. So we would write that as a over x plus 4 plus b over x plus 1. Jumping a few lines here, I hope you're okay with that. We've been doing it a little bit here. Top common denominator times top and bottom here by x plus 1 times top and bottom here by x plus 4. So my top line will originally say then a upon x plus 1 plus b upon x plus 4. I'm going to let x equal minus 1. If I let x equal minus 1, I'm going to get 12 here. Minus 1, this disappears. Minus 1, we're going to get 3b. That gives me a value of b to be equal to 4. I'm then going to let x equal minus 4. Minus 24 plus 18 is going to be minus 6. The minus 4 there is going to make that disappear, so minus 4, so that's minus 3a. That gives me a value of a equal to 2. So we are pretty much there. What was my original question? Therefore, x cubed plus 3x squared plus 10 all over x squared plus 5x plus 4 equals x minus 2 plus 2, which is my a value, over x plus 4 plus 4 all over x plus 1. Just one last comment to this. anytime from now on that you do partial fractions, you need to look to see, is the degree of the numerator greater than or equal to the degree of the denominator? If that's the case, partial fraction won't work for that just yet, the way we do them, so you need to divide through first. And that's our rule for this.